Okay, this is our grade 8 introduction to fractions. We're doing a review of all of the concepts you learned in grade 7. These are some of the few things you might have been able to do in grade 7. So we're going to start one by one and go over the solution to each. In the first question, you have a quarter plus a quarter. Now, if we think about what a quarter looks like, if I was to draw a rectangle and cut it into 4 parts, this would be a quarter. And if I were to take that and clone it, so I'm going to copy it, but clone it and bring it over here, this would be what a quarter plus a quarter looks like in terms of two pictures. When I take this one, and what if I ungroup it? I think I can. Yes, I can. If I was to slide this one over here and say, what is a quarter plus a quarter? The answer would be I have 1/4 here and 1/4 here. So the answer is I have 2 quarters. Or, if I rethought it, as what it really looks like, it's really, or I could say it's half of whatever it is I'm collecting. A quarter plus a quarter is equal to a half. Now, the algorithm you learned, besides drawing it, you learned how to draw it first. That was the most important part because then you visually understood what it was you were doing. And then they said, well, instead of always having to draw it, the procedure for adding two fractions together is if the denominator is the same, keep the denominator and add your numerators, and you will get the solution. If your solution is not in lowest terms, meaning there is a number that's divisible into both the numerator and denominator, do so to reduce it down to lowest terms. So because 2 and 4 are both divisible by 2, our solution for this would be 1/2 in lowest terms. Okay? So when we get to the next one, if we're like, okay, I can draw that if I want, I could draw 3/10 and draw another tenth and add them together. Or I can keep my denominator, add my numerators, and I will get the answer of 4/10. Ask myself, is 4/10 in lowest terms? The answer is no, it's not, because both 4 and 10 are divisible by what number? 2, because they're both even. So when you divide it by 2, you end up with a solution of 2/5. Okay? 4/10 is the correct answer, but 2/5 is the correct answer in lowest terms. Question 3, this time we have 3/5 plus 1/10. So here, if I was to think what we have, if I was to divide these into fifths, 1, 2, 3, 4. I'm going to take this and just clone it real quick. Clone and bring it down here. If I was to cut these into fifths cut into half, I now have 3/5. Actually, let's use a highlighter. Highlighters are kind of prettier. I have 3/5 right here. And I have an additional 1/10 down here. If I'm going to combine those, what would it become if I combine them? Well, in order for us to do that, I have to have the same size pieces. But the nice thing is if I cut all of these fifths into half, I now have tenths in both pictures. Here, I would have 6/10, which used to be 3/5, but they're equivalent fractions. And here I have 1/10. So in essence, instead of doing 3/5 plus 1/10, if I could take the equivalent fraction of 6/10 plus 1/10, I would get my answer of 7/10. And I could actually grab this and bring it over here to see that when I take 6/10 and add it to 1/10, I get 7/10. Now, of course, again, you learned how to start by drawing the pictures, and then you realized afterwards that there was an easier way to do it. So you said, instead of actually drawing it, what I will do is I will find a common multiple that 5 and 10 share. I'll write out all the multiples, and your teacher made you do probably 5 or so. I'm only going to do 3 and then. And you look for the first multiple they share. Now, in this particular question, the first multiple that, that's not right, that 5 and 10 share is 10. And why you did that was because that is going to be your lowest common denominator. So you say, okay, I'm going to rewrite this expression, but instead of using 2 fractions that have different denominators, I'm going to use 2 fractions that have the same. Now, as it stands, because you're using 10 as a denominator, the equivalent fraction to 1/10 that has a denominator of 10 is, well, 1/10. And then over here, you're going to say, well, 3/5 is equal to how many tenths? And we realized when we drew that, just to go back to our drawing when we started with, if I was to highlight 3/5, that represents 3/5 of something, 3/5 of a tank of gas, 3/5 of a pizza, whatever you want to think of it as. And if I was to cut that down, each piece in half, I'm not changing the amount of yellow or the amount of material I have. I'm just changing the way to express it. So in our picture, we can see that it's 6/10, right? We can see that. But the way we do that without a picture or creating equivalent fractions is we say, what did we multiply 5 by to get that common denominator? It was 2. And in order to maintain equivalency, I do the same thing to the numerator. So I end up with 6/10. So once we have those common denominators, 3/5 plus 1/10 becomes 6/10 plus 1/10. Same thing as the last questions. Keep your denominator and add your numerators, and you get the final answer of 7/10. In our next question, we just have a mixed fraction of 1 3/4. It says create an improper fraction from that. And then you are given in the second question the improper fraction of 19/5 and asked to write it as a mixed fraction. So we'll start with the first one, 1 3/4. If I have 1 3/4, and what I will do is I'll cut it into quarters because that's what my denominator is. This picture right here would represent 1. All right, so that 1 right there is represented by a whole unit of whatever it is, a full tank of gas, 1 tank of gas. Plus, we would have 3/4 of a tank of gas, which I will represent with this second part, okay? So when we have 1 3/4, this picture represents the entire 1 3/4. But if you express it as an improper fraction, what you're really asking is how many quarters do you have in total, right? So this is a quarter, 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 and this is a quarter. So if I was to say, what is 1/4 plus 1/4 plus 1/4 plus 1/4? If I was to combine all of those quarters, what would I have? Well, what we've learned with addition of fractions is if your denominator is the same, keep it and add your numerators, and you would get 7/4. How many quarters in total do you have? You have 7/4. So from a visual standpoint, that's how you would solve it. But what your teacher in grade 7 probably taught you was this. If you want to change a mixed fraction to improper, or maybe grade 6 teacher, because you did in grade 6 as well, is multiply your denominator by your whole number. So 4 times 1 is 4. Multiply those together, and then add your numerator. So 4 times 1 is 4, plus 3 is 7. And then keep your denominator as is. The problem with using it that way is that people don't understand what it means. And you do it, you can do it, you can get an answer, but you don't understand what it means. And then for some of us in grade 9, if I gave you negative 1 2/5 and asked you to change it to improper, some people go, well, 5 times negative 1 is negative 5, and negative 5 plus 2 is negative 3. And they say that this is the answer, and that's wrong, right? So you can't use that process with everything, especially when they're negative. But it does work for these ones, so your answer is 7/4. Now the reverse is interesting. So you have 19/5. Now, if I was to draw something that was cut into fifths, there it would be there, and I would say this is 5/5. But since I have 19/5, I'm going to clone this. What's this picture represent? All of it. What's that picture represent? 10/5. Correct. And if I clone this again, what's this picture represent? 15/5, or 3. Agreed? 3 whole objects. 15/5. How many do I have for my improper fraction? 19/5. So I'm going to draw it one more time. I'm going to clone it one more time and ask you, what picture is this? It is 20/5. So if I was to draw this as a improper fraction, this picture that I just drew would be 20/5. 1/5, 1/5, 1/5. All together, I would have 20/5. But I don't have 20/5, I have 19/5. So if I grab my eraser and erase this last one here, I now ask you the question. This is 19/5, agreed? How many whole units do I have, or how many whole parts? 3. And how many fractional parts? 4/5. So as a mixed fraction, we would express that 19/5 as being 3 wholes right here, plus an additional 4/5. All right. How did your teacher teach you how to do it without actually drawing it and thinking of it that way? What was the algorithm? You would say, how many 5s in 19? without going over? 3. And 3/5 is 15. How many more to get to 19? 4. That's your numerator. Okay. So that was the process for changing mixed and improper fractions to each other. The middle question says draw the solution. So we're going to draw half. And I'm going to keep this rectangle exactly the same size. I'm just going to clone it real quick. Bring it down here. So for 1/2, I'm going to cut it in half. I'm going to shade it in with yellow. Hopefully. There we go. And for the other one, I'm going to make it into fifths. I'm going to shade it in for yellow. So what do I have to do in order to be able to add those two together from just a picture standpoint? What do I have to do, Hayden? I have to make both of them into the same size parts. And if I think back to my common multiples, what number is that going to be? 10. So I'm going to cut both of these into 10 equal slices. So I'm going to use this one first. How do I cut it into 10 equal slices if it's already cut in half? If I put 4 lines down, how many parts does that make in that section? 5. And if I do the same thing for over here, 4 lines make 5 parts. So that right now that's cut into 10 parts. Agreed? And over here, I'd have to cut each of these into just 2 parts, and I would have 10 pictures. So what did 1/2 become when I cut it? It's now 5/10. And what is 1/5 when I cut it? 2/10. So what is 5/10 plus 2/10? Equals 7/10. So your solution to that is 7/10. That's from drawing it only. Okay. Which brings us to our next question, which says 1/2 plus 3/8. Now, when adding fractions that are mixed and improper, or mixed and proper, your teacher last year told you could simply add your whole numbers together, right? And add your fractional parts together, and you'll get the answer. I like that too, but the only problem is for subtraction, it doesn't always work, because why? You need to borrow sometimes, right? And if you had Mr. Coyle for a teacher, he said borrowing's no problem. He taught you how to borrow, right? And it drove people crazy because it was kind of confusing. My opinion is that I never use mixed fractions. I always just use improper because it makes my life a lot easier. But what I would recommend for addition is just go 1 plus 1/2 plus 3/8. Bring your whole numbers down if you're adding them, and then add your other parts together. So here, our common denominator will be 8. I will get 4/8 plus 3/8, which is equal to 1 and 1/8. Sorry, that's not true. It's equal to 7/8. Agreed? Then you take your 1 plus your 7/8, and you will get the solution of 1 and 7/8. That's one way to do it. The other way you can do it, which works just as well, is you never add or subtract mixed fractions. You always just change them to improper. And the reason why I say that is for addition, it's not necessary, but for subtraction, it makes it much easier. So for kids who struggle, just always change your mixed fractions to improper, and life will be easy. How many halves are there in 1/2? How many halves exist? 3 halves. So we would say 1/2 is actually equal to 3 halves, plus an additional 3/8. So instead of doing 1/2 plus 3/8, I'm going to do the improper fraction. Common denominator will be 8. The equivalent fraction to 3 halves is 12/8. Add your numerators. You get 15. Add your denominator, or keep your denominator, you get 8. 15/8 is an improper fraction. Your solution is still 1 and 7/8. The exact same answer you got, but you took a completely different pathway to find the solution. Okay, next question. So 1/2 take away 5/5. This is a subtraction. So that whole number thing and the borrowing thing, if you want to do that because you really like it, go for it. But I recommend highly when subtracting mixed fractions, never use that. Just use the same method we just talked about. So I'm going to convert this. Instead of using 1/2, I'm going to use 3 halves. Take away 5/8. So this question is exactly the same, but it uses improper fractions instead of mixed. Common denominator will be what? Between 2 and 8. What's the first multiple that they share? 8 it is. So the nice thing about 8 is the second fraction of 5/8, does it change? No, it stays 5/8. But the question we now have to ask ourselves is, what is 3 halves as an equivalent fraction with 8 as a denominator? You multiply 2 by 4, therefore you multiply 3 by 4. So the equivalent fraction of 3 halves is 12/8. Now that you have common denominators with equivalent fractions, you're going to keep your denominator, subtract your numerators, and your final solution will be 7/8. Everybody okay with that? Did anyone do it differently? Did anyone use that borrowing method? You did? You don't mind it? You like it? Keep filling your boots with it then. It's fine. It's no problem to use it. I just appreciate the simplicity of changing mixed fractions to improper and just using the same algorithm as you would for regular fractions. Here we have a BEDMAS question with addition and subtraction. We know that we're supposed to do addition and subtraction in the order they appear from left to right. But what we're going to do is we're going to first change this entire thing to equivalent fractions with the same denominator. So I'm going to use 8 as my equivalent fraction. Last one's not going to change. 1/2 is equal to 4/8, 3/4 is equal to 6/8, and 7/8 stays the same. Now that your denominator is the same, and you're adding and subtracting only, I'm going to keep the denominator and add and subtract the numerators. 4 plus 6 is 10, and 10 minus 7 is 3. So your final solution to this question is 3/8. And finally, your last question, the subtraction of two mixed fractions. If you are into the whole borrowing thing, go for it. Or if you're embracing the newfound method of just changing everything to improper, 4 3/5, 5 times 4 is 20, plus 3 is 23, over the original denominator 5. Take away 16 plus 7 is 23, over the original denominator 8. Is that right? Did I do that right? 16? Yeah, they're both 23. I didn't realize that. Interesting. Now that you have that, what's your common denominator going to be? Between 5 and 8. What's the first multiple 5 and 8 share? 40. So because it's the first multiple they share, it's going to be my lowest common denominator. Numbers get a little bit big here, but that's okay. You're smart people. I know that 5 times 8 is 40. So 23 times 8 will be my equivalent fraction. 20 times 8 is 160. 3 times 8 is 24. 160 and 24 is 184. Over here, to get to 40, I had to multiply 8 by 5. I'll do the same thing with 23. It's going to be 115. Now that we have our two equivalent fractions that have a common denominator, I'm going to subtract my numerators and keep my denominator. Can I do that in my head? 69 over 40, is that right? Which of course will simplify because that is an improper fraction. Will be 1 and 29/40 when you change it from improper back to mixed. Both answers are correct.